In this video, we're going to discuss evaluating double integrals using polar coordinates. For this example, we're going to evaluate the double integral over the region R of x squared dx dy, where R is the right half of the ring of x squared plus y squared between 1 and 9. We can begin by plotting what this ring will look like. So the ring as a whole looks like what is pictured, but we're only concerned with the right half of the ring. If we take a closer look at this region, we can see that the right half of the ring, the region that we're interested in, can be represented in polar coordinates as theta going from negative pi over 2 to pi over 2, and r, which is the radius, goes from 1 to 3. So we have that theta is between negative pi over 2 and pi over 2, and that r is from 1 to 3. Now, since the region that we're integrating over is a ring, it's natural to use polar coordinates. Anytime that there's a circle or something circular, like a ring or a quarter of a circle, it's usually a good idea to consider using polar coordinates. So to do this properly, we can let x equal to r cosine theta and y equal to r sine theta. We can now use this information to rewrite the double integral as an iterated integral. So we can rewrite our double integral as an iterated integral, with the outer integral going from negative pi over 2 to pi over 2, which is the change of theta, and our radius r going from 1 to 3, and we substitute x with the variable that we chose from the last screen, which was x equals r cosine theta. And then since we're in polar coordinates, we have to add an extra r into the integrand. From here, we just do simple calculus 2 techniques to solve the inner integral first. So doing this, we get the integral from negative pi over 2 to pi over 2 of r to the fourth divided by 4 cosine squared theta, and then we need to evaluate from r equals 1 to 3, and then still do another integral with respect to theta. So after some simple arithmetic, we come down to the integral negative pi over 2 to pi over 2 of 20 times cosine squared theta d theta. Now, using a half angle formula from precalculus, we see that we get the solution of 10 times theta plus sine theta times cosine theta, which still needs to be evaluated from negative pi over 2 to pi over 2, giving us a final answer of 10 pi. So from this, we can conclude that our evaluation of the double integral over the region R, which was the right half of our desired ring of x squared, is equal to 10 pi.